So section 1.4, let's talk about matrix equations. So equations, it has an equal sign. The fact that it's a matrix equation, everything in the equation will be a matrix, okay? So let's take a look before we get there. What you see on the left, this is pure algebra 1. A, X, and B are all numbers, okay? If you're told to solve this for X, what do? Yeah, yeah. So if these are all numbers, you have AX equal B. The next thing you're told to do is divide everything by A, and you get X is equal to B over A. Algebra 1 stuff, okay? Isolate the variable so you can subtract things on both sides, you can divide. Now, what's the one operation that we don't have for matrices? Division. We've talked about addition, subtraction, multiplication. There is no division of matrices. So I cannot, if these are matrices, I cannot divide both sides by matrix A. So I can't do that. But what we talked about yesterday was finding the what? The inverse. So what if I did this? What if I did A inverse times AX equal A inverse times B? So what did I do? I multiplied both sides of the equation on the left side by what? A inverse, okay? So that's a valid operation. When you have an equation, you can multiply both sides of an equation by the same thing. Now, why did I pick multiplying by A inverse? Why did I do that? What is A inverse times A?
It's like dividing.
When you multiply a matrix and its inverse, what do you get? Which is the identity matrix. So Maxwell got it. So when you multiply A inverse times A, you get a matrix that looks like, A inverse times A is going to look like this, and zeros everywhere else. Okay, it's going to be that. It's going to be the identity matrix, whatever size that is. And that matrix, it has the property that when you multiply it by a matrix, what do you always get? When you multiply any matrix by the identity, same thing you started with. It's the matrix equivalent of multiplying by 1. Okay, so A inverse times A, that is the identity matrix. Okay, so I'm just going to write an I there. So that is the identity. So I get what is the identity matrix times X? What did you tell me? When you multiply a matrix by the identity, what do you get?
1 or the same thing.
Yeah, same thing you started with. So what is the identity times X?
X.
It's X. So this gives you X is equal to A inverse times B. That's how I solve for X. Okay. Now you're not going to have to go through these steps every time. You should be able to go from here. You should be able to let your thought process take you there. Instead of dividing by matrix A, we multiply on the left by A inverse. Now what would happen if I did this? If I had AX equal B, what would happen if I multiplied that's valid. I multiplied on the right by A inverse, but did that do anything for me? No, I mean, so this is not the identity. This is something, but this doesn't help me. It's a valid operation, but you can see why I had to multiply on the left side. So it's very important when you go from this step to this step, it's A inverse times B, not B times A inverse. And remember, with matrices, we don't have that commutative property that we can switch the order that we multiply. So does this make sense what I went through here? You're not going to have to derive this every time. So instead of, like if these were real numbers, you divide by A and you're done. But I can't divide by matrix A. So I have to multiply by an inverse. That was the reason we spent time finding the inverse. A inverse times A, that's the identity. That's the matrix that's equivalent of multiplying by 1. So the identity times X is just X. So the way you solve this is X is equal to A inverse times B. Everybody with me on that? Okay, that's why we found the inverse, so we can now solve equations that involve this. So I want to solve this equation. So think of this as AX equal B. So to solve that equation, X will equal what? That's how I solve that equation for X. Okay? So I need to figure out X equal, what is A? A is 5, 7, 2, 3 inverse times 4, 0, 12, 6. So again, you should be able to go from this equation to this is how I solve for X. X is A inverse times B. So now what do we have to do next? What do I have to find? I have to find the inverse of this matrix and then do what? Multiply it. So I got to find the inverse of that matrix. So what was our first step for finding the inverse? I need to find the what? The determinant of that matrix is what? It's 15 minus 14, right? So that determinant is 1. Okay? So that means that X is equal to 1. So it's 1 over the determinant. That's 1 over 1. And then what do I do with this matrix? What happens to the 3 and the 5? They switch places. And then the 2 and the 7, they get negative signs. And then I copy down that matrix right there, 4, 0, 12, 6. So that's why we spent time yesterday finding the inverse, because there is no division with matrices. So we need to be able to find the inverse in order to solve matrix equations. So now this becomes a what? What operation do I do? Matrix multiplication. So you can see why we started out adding matrices, multiplying matrices, finding inverses of matrices. All that leads up to this big exciting day that you have before you, where we're solving equations and pulling all of that together. So if you haven't told, I can be sarcastic at times. So hopefully you're picking up on that. So X is equal to, now where are you now in matrix multiplication? Do you just do this? Do you do this in your head? What do you do next step? Do you write down everything? How are you doing it? Write down each step. So let's do this. So first thing I'm gonna do is first row, first column. So that's going to be what? 3 times 4 plus negative 7 times 12. That's the first element. Okay. And then to find the next element, first row, second column, that's 3 times 0 plus negative 7 times 6. Let's go to the second row. Second row, first column, that's negative 2 times 4 plus 5 times 12. And then second row, first column is negative 2 times 0 plus 5 times 6. And now it's arithmetic. And if you need a calculator for this, you can certainly do it. What is 7 times 12? That's 84. Is that right? So this is 12 minus 84. Did I have my calculator? That's negative 72, right? So I'll go back. So that's negative 72. This is 0 minus 42. That one's pretty easy. And this is what? 60 minus 8. Is that 52? And this is 30 minus 0. That is 30. There we go. Okay. So what we did new today was use the inverse to solve an equation. Okay. So is this hard, easy? What do you think about this? Not that bad. There are places mistakes can be made. And most of the mistakes people make in this unit are what kind of mistakes? Arithmetic, careless errors, so the concepts are not that difficult. Most people do pretty well on this assessment, but where it breaks down is the arithmetic. You've seen me make mistakes in class, okay? That it will happen. But, what I will do, I mean, if you got the wrong number here, I'll follow your math and, okay, it was a minor arithmetic mistake. So, you won't be hung on a cross for making an arithmetic mistake. So I'll follow through. You get partial credit. Don't sweat on that kind of stuff. So let's do a couple of extras of these. Solving this equation, okay? So to do this, the first step is to isolate x. So x will equal what? What do I do to solve this? The inverse of this guy. So it's 5, 7, 2, 3 inverse times 2, negative 1, 1, 4. It's very important that the inverse is the first matrix you write down. If you write it after that matrix, you're going to get wrong answers. So it's x is the inverse of this matrix times that matrix. So let's find the inverse. To find the inverse, I must first find what? The determinant. So the determinant is going to be what? 5 times 3, that's 15. Is this the same problem? It's the same problem, isn't it? Is it different? Oh yeah, the second matrix is the same. Okay, yeah. So anyway, I know the inverse. So anyway, so the determinant is 1. So this is going to be x equal 1 over 1. We determined the inverse of this is what? 3, 5, negative 2, 7. So I didn't have to go through that process again. The inverse was the same, but it's just multiplied by a different matrix. And so let's do this. So it's 3 times 2 plus 7 times 1. And then 3 times negative 1. It's, oh, you're right. Again, that's me making mistakes. So it's, thanks for that. So it's 3 times 2 minus 7 times 1. And then first row, second column is 3 times negative 1 minus 7 times 4. And then second row, first column is negative 2 times 2 plus 5 times 1. And then negative 2, negative 1 plus 5 times 4. This is 6 minus 7, which is what? Negative 1. This is negative 3 minus 28, which is negative 31. This is negative 4 plus 5, which is 1. This is 2 plus 20, which is 22. Okay? And there's our answer. Okay. So most of the stuff in this section, like I said, I don't like to rate things and say it's easy, but they're straightforward. There's not a lot of variation. Okay. If you can get the process down, it repeats. The numbers change, places mistakes can be made, but pretty repeatable. So the key here again is when you see AX equal B, and these are matrices, you don't have to write down A inverse times AX equal A inverse B. You should be able to take that and just go straight from here to here. That's how you solve for X, okay, by multiplying on the left side by the inverse of the matrix A that you see there. Let's see another example here. A and B, solve the equation AX equal B. So to solve this equation, X is equal to A inverse times B. So all we have to do is find the inverse of A, multiply by B. So if I look at A, so X is what? 2, 2, 7, 8 inverse times 4, 12, 10, 20. So to find the inverse of this matrix, I must first find the determinant. So the determinant is going to be what? 2 times 8 minus 2 times 7. That's 16 minus 14, which is 2. So the determinant is 2. Right? So this inverse, so it's going to be x equal 1/2. Don't let the fractions scare you. They're harmless. And then what do I do with this matrix? I switch the 8 and the 2, and then I put a -2 and a -7. Right? Times 4, 12, 10, 20. Now I got a choice. I can multiply the 1/2 in this matrix. What would that give me? Starts with an F. Fractions. And then I can do this multiplication that has lots of fractions. Or what else could I do? Yeah. Multiply these two matrices. Hold this fraction out until the last step. That is what you want to do here, okay? So x is going to be equal to 1/2. And then let's go ahead and do the multiplication. 8 times 4 is 32. -7 times 10 is -70. Okay? Let's go first row, second column. 8 times 12 is what? 96. 7 times 20 is 140. Okay. -2 times 4, what number is that? -2 times 4, -8. -8 plus 20. So it's -8 plus 20. And then second row, second column, that's -24 plus 40. Am I going too fast? You got it? Yes. Oh, you're stretching? Okay, that's fine. So 32 minus 70. That is what, 48? Is that right? -48. Oh, it's -38. Sorry, you're right. And you can have a calculator to make sure you don't make mistakes that I'm making. 96 minus 140, that's -44. 20 minus 8, I can get that one. That's 12. 40 minus 24 is what, 16? Is that right? And now what do I do? Now I take that 1/2 inside this matrix. So what is 1/2 of -38? -19. 1/2 of -14, -44. -22. Half of 12 is 6. Half of 16 is 8. And that's my answer. Okay. So anytime the determinant gives you a fraction, hold that out to the very end. Okay. You don't have to do that, but it will punish your arithmetic if you don't do that. So hold that fraction out until the very last step. Now, what's different here? Everything we've been doing has been what? 2 by 2, 2 by 2. So this one, I'm trying to solve AX equal B. What's the dimension of A? 2 by 2. What's the dimension of B? 2 by 3. What must X be? So first of all, for this to be valid, it has to be a 2 by something, right? And for it to get a 3, it has to be this. So it has to be this. So X has to be a 2 by 3 matrix. Now, we can't take inverses of matrices that aren't square. Is that a problem here? No, because what matrix do I need the inverse of? A, not B, okay? So I need to find the inverse of A. That's fine because that's a square matrix. So X equal A inverse times B. So that means that X equal 1, 2, -1, -1, inverse times b. All this probably means is the matrix multiplication just has more arithmetic in it. So to find the inverse of this matrix A, first step is to find what? Yeah, so the determinant of that matrix A is going to be what? 1 times negative 1 minus negative 1 times 2. Okay, so that is what? Negative 1 plus 2, which is 1, right? Do you like it when the determinant is 1? Yeah, that means there's no fractions, so it's the determinant is 1 over 1. So x equal 1 over 1, and then what's the matrix that goes next? Yeah, the negative 1 and 1 switch places. This negative 1 becomes 1, and that 2 becomes negative 2. And then I multiply that by 4, negative 7, 9, negative 2, 4, negative 5. So this is a 2 by 2, 2 by 3. The answer we determine is going to be 2 by 3. So it's going to have something in the first row, first column, first row, second column, first row, third column, second row, first column, second row, second column, second row, third column. So I just need to go find all of those numbers. It looks like I'm going to need to use some extra space here. So let's find these numbers. So let's find this first element. That's going to be the first row with the first column. So that is negative 4, negative 4, and positive 4. Okay. Now let's go find first row, second column. So first row, second column. Negative 1 times negative 7, and then negative 2 times 4. Now let's go to first row, third column. Negative 1 times 9, and negative 2 times negative 5. Okay. Now we move to second row, first column. 1 times 4 plus 1 times negative 2. And then we move to second row, second column. Second row, second column, negative 7 and plus 4. And then last second row, third column. That's 1 times 9 plus 1 times negative 5. So this is what? 0, negative 1, 1, 2, negative 3, 14. I know the after lunch excitement is overwhelming you. These are repeatable, right? Same step.
How'd you get 14?
Did I make mistakes? Second row, third column. 1 times, oh, you're right. 1 times 9 plus 1 times negative 5. That's not a 14, that's a what? 4. Thank you for that. So yeah, and that's where, see what I did different here was I did negative 1 times 4 and I just wrote it down. If you have to write down, if it's helpful you to write like this, negative 1 times 4 plus negative 2 times negative 2. If it's helpful you to write that intermediate step before you get here, then by all means do it. However many steps you need to keep from making the mistake that I just made there is helpful. So, and you can always go back and check your arithmetic. So that's probably the thing that trips most people up in this section is just making those arithmetic mistakes. I think there is just one more, and then we're turn you loose into the homework. So solving this matrix here, To solve this for x, what is x is equal to what? X equal A inverse times B. So x is equal to 16, 4, 8, 2 inverse times negative 1, 7, 1, 0. So to find the inverse of this matrix, the determinant of A is, what is 2 times 16? 32 minus, what's 8 times 4? 32. That is 0. There are bells going off in your head now because why? Yeah, the determinant is 0. That means there is no what? Well, if the determinant is 0, I can't find the inverse. If I can't find the inverse, I can't find the what to this equation. Start with an S. Solution, answer. Yeah. So there is no solution. Okay. Undefined would be, if you wrote undefined, no solution, whatever. So remember yesterday, if the determinant is 0, there is no inverse. If I can't find the inverse, I can't solve this equation. So remember when you did equations in Algebra 1, you had 2 lines. Sometimes there was no solution, right? If the lines were parallel, there'd be no solution. That's what this is mimicking here. So if the determinant is 0, there's no inverse, therefore there's no solution. So believe me, these are, you want to like these problems, you know. In this section, undefined and no solution, you should want more of those on this assessment, okay?